In this paper, we study how to mitigate unconscious human biases during visual data analysis. We integrate an intervention, interaction traces, a visual footprint of a user's interaction history, into a visual analytic tool, and study how it can be used to impact user behavior, decisions, and increase awareness of potentially unconscious biases. We study the effect of this intervention both in lab and through a virtual crowdsourced experiment across two dataset domains, politics and movies. For this video, I will give an example using the political scenario. In the political scenario, we asked participants to choose a committee of 10 fictitious politicians to review public opinion on the recent Georgia House Bill 481, which banned abortion in the U.S. state of Georgia after 6 weeks. We expected to observe things like bias toward a particular gender, bias toward people's own political party affiliation, bias toward particular age groups, and so on. We developed an interactive scatterplot-based visualization system. The primary view is an interactive scatterplot where each dot represents one data point, in this case, a politician. When you hover on a point in the scatterplot, details about that politician are shown down below. To select the politician as part of your committee, users can click on the corresponding scatterplot point or on the button in the top right of the detail view. And you can see the list of politicians that you've chosen on the right. On the left-hand side, there are filters, so people can adjust if they want to only look at a particular subset of the data. In addition to this control interface, we designed and implemented a real-time and summative intervention that visualizes interaction traces. The goal with showing users traces of their interactions is to see if we could increase their awareness of what data they've interacted with that might be telling of implicit bias. We showed real-time interaction traces in the interface in a couple of ways. We showed in situ interaction traces in the scatterplot by coloring points based on how many times the user has interacted. The colors change from white to blue as users interact more with a given point. We also showed ex situ interaction traces by adding an additional view to the interface in the top right. We used gray to represent the underlying distribution of data and blue to represent the distribution of the user's interactions. This view will compare these two. As the user interacts with the data points, in this case politicians, in the scatterplot, the blue bars will update in real time. So let's select one attribute up at the top, party. The gray bars indicate that the dataset has more Republicans on the right than Democrats on the left. But the user's interactions so far in blue are skewed heavily toward Democrats. The intensity of the orange coloring of the attribute tags in this view reflects how much the user's interactions deviate from the distribution of the data for that attribute. So light orange or white means that there's little to no difference in the distribution of the user's interactions and the distribution of the data. And a darker orange color means that there's a bigger difference. Summative interaction traces look similar to the ex situ real-time interaction traces, but they're shown after the user has selected their committee of 10 politicians. After seeing these summative interaction traces, users have the opportunity to revise their committee selections. We conducted a series of experiments to study the effect of interaction traces on people's interactive behaviors, decisions, and general awareness of potential biases. While results were ultimately inconclusive across our experiments, we find some mixed support that interaction traces, particularly in a summative format, can increase awareness of potential unconscious biases. In this video, we focused on walking through the interface. For details of our user studies and analyses, please read our paper. Integrated into future data analysis and visualization tools, these results can have far-reaching implications toward mitigating human biases in decision-making contexts such as healthcare, hiring, criminal investigations, and so on.